Hey, so this video is going to go over all of the features of the Java Corruptor, including features that are basically just mirrors of existing features in RTC. So if you've already used RTC, you already know how like sanitization and stuff works and stockpile, you might want to skip over some parts of this. But yeah, so first we're going to talk about intensity. Intensity is, you can see, represented by percentage points. So at 100%, it's going to corrupt the entire game, and it's going to be basically completely unplayable. At 0%, nothing's going to happen. It's going to be like you just launched the original game. A good value is usually somewhere around like 0.5 to like maybe 5, but it really depends on your engine and what settings. And speaking of, we can go to the engines now. The basic engine we'll start with because it's basic. You know, you just select instruction here, and you can select other instructions here, and it'll hide all of the instructions that would be incompatible and would cause the game to completely crash. The best ones usually are the ones starting with F and the ones starting with D, because these are floating point operations, you know, numbers with decimal points. So if I were to select these and these, or, you know, let's just start with these two, right? So this would go over the entire game and replace about 5.2% of the additions in the game with subtractions. So you can imagine in a game where you have healing items, your health's a number. So when you take a healing item, it will add some number to your health. And so if you take like a healing item, for example, the game is going to be adding some number to your health. And so this engine might, you know, if it hits it in the 5%, it will replace that addition with a subtraction. So maybe healing items might make you take damage, and, you know, it'll do that for all sorts of things. Often like stuff to do with rendering code. It's you know, very, very simple. All of these will work well. The ones starting with F will also work quite well. If I can find them, yeah, these ones, actually these would be more common even. So now we can talk about the Arithmetic engine. It's a little more complicated, but it's not too difficult to understand. So this one, you can imagine if I just select the math operations, this will take math operations like add, addition, subtraction, multiplication, and do stuff to them. So we can select the specific ones, and if I disable that, that'll be grayed out. We can say, okay, whenever we see an addition, subtraction, or multiplication, we can add or subtract a number between these two numbers. So between -2 and 2. And with that healing item, that might now, instead of healing you by, you know, say 5 health points, it might heal you by 5 plus 1.5 health points, or 5 minus 0.38. Or you can multiply it. And so you can, you know, set it to something big, you know, whatever. Doesn't really matter. And all of these are just different types of instructions that it can work on. So it could work on when moving numbers around, or, you know, basically just select the ones that are by default. I forget, but select the default ones and you'll be good. Over here we can select the different data types. Float numbers, double numbers, those are the decimal points I was talking about. Those ones will work the best, but we also have instant logs, so those are numbers without decimals. Those will cause the game to crash a bit more often, but they might give you more unique results when the game doesn't crash. Randomized value at runtime, this is a checkbox that exists in a lot of the engines. With that unchecked, it's going to choose the same random number every single time the code is ran. If we corrupt that healing code, and it's set to addition with, 3, right? It adds 3, it's always going to add 3 no matter what. But if we check this, then it'll choose a different number every single time that code is ran. So next we can use the function engine, and we can see it's just math functions. So you've got, you know, cosine, sine, all sorts of different things. At least for Minecraft, it's not that interesting, but you can get some results from it. Usually you'll want to increase the intensity of maybe like 50 or something. You may notice that this isn't actually at 60%. Like if I do it to 50, it's more like 75% of the way through. That's because the lower values, it makes it easier to select more precise numbers, since normally you're going to be sliding the slider around here. That just makes it so you don't have to slide it like right over here to get the numbers you want. You can have more pixels to select a more exact number. So the custom engine I'll get back to later, because as you can see, it's a little bit complicated. So we can go to the string engine. This corrupts text. To explain this, I'm going to pull over a notepad window, and I'm just going to write, I don't know, hello world. Right, so with nightmare mode, we have a percentage here, and that's how much of the text it's going to corrupt. Nightmare, it's going to select random characters from here and replace random characters in here with them. So maybe it'll have 20%, and maybe it'll take that one, replace it with a, I don't know, a P, that one, maybe replace that with a 1. You get the idea. Swap, that'll swap characters in the text. So maybe it would take this one and the W and make it say hello world, then maybe these. Then we also have cluster, and that's basically the same thing as swap, except it applies to only adjacent characters. So it might say, I don't know, hello Wordle, and then 1 per line, you would put like 1, 2, 3, ABC, test, on these, and so that would replace it with one of these. So instead of saying hello world, it might say ABC or test, or 1, 2, 3. And so you can enable runtime randomization on this one too, and that will only enable these two options because it just wouldn't work with the other modes because of how they're programmed. So the percentage, if I increase that to 100%, then you would imagine this entire string would get messed up, and it wouldn't resemble that at all. It would just be random characters. So now we can go to the logic engine, and this corrupts comparisons. So maybe the game checks when you get hit. If your health is less than or equal to 0, then you die. So this might change it so that instead it checks, instead of checking if your health is less than or equal to 0, you might replace that with greater than 0, and then you die in every hit. Or die in every hit unless you get hit so much that your entire health bar runs out, and then you'd survive. Or you can invert it, that would do the same thing, and then, same thing here. Floating point comparisons versus integer comparisons versus booleans. So booleans are, I guess, true or false values. Those can also work well. And then Nucar engine, this looks really complicated, but it's not. In software and games, code is split into sections called functions. And so often those functions will return some value. So you might give two numbers to a function called multiply, and then it will return those two numbers multiplied together. This will replace the entire function with just one value. So if it returns a float or a double, normally it might do some complex calculations, actually run code. This will make it not do that, and it'll just return some value, the same one all the time, or a random one. We can also do that for strings, and that does basically the same thing as the string engine. Actually, this works significantly better, but yeah, we can do one per line, we can do character set, which is basically like the Nightmare Engine mode. If you select that, it'll make this very unfinished menu pop up, and you can select how many characters you want. Runtime randomization is actually enabled by default on this one because I find that it makes it significantly more stable. And for void, that's functions that don't actually return any value, they just run code. And so this will be a lot more crashy, but it can make some interesting stuff happen. Or literally, it'll make stuff not happen. So I'm gonna use this engine. So I'm gonna use Arithmetic because in my opinion, it's the most effective engine. Yeah, we can just maybe set that to like 1.5. Let's go ahead and hit the corrupt button and see what happens. So we've got the panorama has completely wrong colors and it's all messed up. We can join this world and see what's up in the actual game. So the clouds are pink and the world was visible but not for long. And so I do like how the panorama was all messed up in colors. I like this pink and blue and purple. I want to have just that effect. I want to save that. What I'm going to do is, and this is stuff that people who have used RTC before will already know, we can sanitize it. Before corrupting, we're always going to close the game. If we keep the game open, it's not going to work because it can't replace the game's jar file. We're trying to delete it while it's running. Windows won't let you. And we're going to start sanitizing. And so what this is going to do is each corruption is made up of a bunch of blast units. You can see this one's made of 546 of them. They all do different things. They all corrupt different parts of the code. And this is just going to disable half of them and ask you, is the effect you're looking for still present? Let's say that one's actually I can tell it's made of two different effects. We've got the blue gradient at the bottom, and then the panorama was also purple. So I'm gonna say no. I just want the purple panorama. Made that, I forgot to close it. It's not gonna do anything. But we can reload the current attempt. Just replay that because I didn't get to see it. And so nothing's there. So we're gonna say no again. Still not what I'm looking for. Oh, here it's pink. So we can say yes. Not. So we can say no. And so now that I've said yes for the final time, there's one unit left, and it is. Now sometimes you might run into an effect that seems like it's just one effect, but it's actually multiple units working together, and that's a little bit more complicated. You'll want to only click no and try a different attempt until you get down to like 2 or 4 units, and then you will. What I'm going to do now is I'm going to click keep changes down here. That's going to load this into the blast editor, so we can actually edit how this unit works. So it's kind of pink now, but I'm thinking maybe if I increase this number here, well before it said 1.48, right? So it was loading some value and then subtracting 1.4 from it, 1.5. Now I'm going to make it subtract 4.5, and we're going to see what happens to it now. Okay, not a whole lot happened, but that's fine. We can make it add. Well, that didn't do anything. I don't know why. That's all right. We're just going to roll with it. And normally that would have, you would have been able to see an effect. But one thing maybe we can do to see an effect is to re-roll this row. So what that's going to do is we can change the settings that are stored inside of this unit. Each unit has the engine settings used to create it. We can change this to say, I don't know, randomize value at runtime and increase these ranges. So now I can re-roll this row and it'll actually rerun the corruption on that with the new settings. So now we can load and corrupt that, and now that it has a randomized value at runtime selected, we'll see, okay, so it actually was doing something. It was changing the intensity of this green gradient at the bottom. Once you're happy with whatever you've done, whatever you've created, you can go ahead and send it to the stockpile, give it a name. I'll say pink panorama and green gradient. And so that'll put it into the stockpile. And you can save that stockpile as whatever, and then you can load it up after. So maybe you make some corruptions today, then you stop, and then you decide, hey, I want to go look at that back tomorrow, and I want to maybe add more. So then you can load that up and just click on these, and it'll load. I guess I'll show one more thing. You can right click on a unit and click disassemble this unit's method, and you can see the actual code inside of the method. There's this replaces value that changes how many instructions it replaces. So if I change that to 2, then we can see these 2 are selected because it's going to be removing both of these. That would make the game crash because we're deleting this instruction outright, and that's not going to work well. That is something that some of the engines do. Some of them replace multiple instructions. So that's basically the basics. Now I'm going to get into some more complicated stuff. We can see there's this launch software after corrupting checkbox and this path. This is a Java launch script, I've dubbed it, and it basically just runs some programs. We're going to see here, it actually, the plugin created a 1.12 RTC folder to run this corrupted game, or this corrupted Minecraft instance from, and it made a batch file, and that's just, actually I'll open it up here. That is just deleting the original game jar file that's going to be launched. It's going to find the corrupted one and rename it to the original, and then delete all of the other corrupted ones just in case. Then it runs the game. So it runs Java, it selects all of the stuff necessary to run Minecraft, and we have show output disabled there, but if your game's crashing and you don't know why, you could enable that, and so that will display all of the logs in here. You could also just look at the logs in the .minecraft folder, but this is a little bit more convenient. That's disabled because it could maybe cause the game and this to lag a bit. Then we can now cover the custom engine. You don't have to watch this, but this lets you do basically anything you want. We can actually drag this out and increase the size and actually just make that bigger. So we are finding any add instruction. This is a regex, and if you know regex, you'll know that it's just finding an I, L, F, or D add instruction. So it's an int, a long, a float, or a double, and it's storing it in the first capture group. So now we can say, replace that with a subtraction instruction of the same type. We're using these angle brackets to surround the regexes and these capture groups. Also use them to run the syntax. So this is like you can think of these kind of like preprocessor macros. So this is just checking what the value of that capture group was. This could be any length. It doesn't have to be surrounded in quotes. And so this is converting the output of this subtraction instruction to a double. It's going to say I, L, or F to D, so that's going to convert any of those to a double number, as long as it's not already a double, because there's no double to double instruction. If it is a double, then it'll just do nothing, because it's already the right type. Then we get a random number, we multiply it by the random number, then we do another one of those checks, and we also use this random macro that'll create a random number, kind of like the Arithmetic engine. And you can actually use the capture group inside of this macro, so this is going to create a random of whatever type it is. If you were hard coding this, you could do random I, random D, random F. This is going to select the right type and create a number between 1 and 10 exclusively. Load a constant value with that number and of that type. That might be load C 3.5D or 3.5F or 7I. Then we'll add that new random number, and then over here we're getting a random number, comparing it to 0.5. So this is half the time, it'll add 3, and we're doing that using this label macro. Technically, you could name this label directly, and it would kind of work. You could just do this, but it won't work that well. Windows text boxes don't have undo, so be careful. So the first time it sees this, it will create an identifier for this label that will be unique for this pass of the engine. If you didn't do this, if the engine got multiple hits in the same function, it would crash, because it would be trying to define this label more than once, and it'd be trying to jump to one of them, and that's obviously bad. Once you've made this, doesn't have to be as complicated as this, could be really simple. You can check for errors using this big red button that'll turn red whenever you make a change, and we can see no errors found, but that's not interesting. We want to see what happens if you do have errors, so we can just replace it with, whatever, not a valid instruction. Check for errors, and we can see it ran it on every single instruction in the entire game, and found that every single time it had an error, because is not a real instruction, if you can believe. It's an unknown opcode. So it'll show you how many errors there are, it'll show you what all of them are. So let's make maybe a more subtle one. Let's say, 5.2i. So that'll try to load 5.2 as an integer, which is obviously not valid because it has a decimal place. Errors. We'll see, 5.2i has an invalid integer constant 5.2 because it's not an integer. So we can see more, whatever. So if you have multiple errors in it, then that can be useful. This won't turn back until you make it actually work. So if I do 5.2f, then it'll be okay, and it'll turn back to being gray or whatever color you have. You can customize the color. And one more thing. We open the settings and domains thing, we can see we have a few different settings, all stack frames, The JVM requires a method to contain stack frames and the max size of its stack to verify its integrity. Most corruptors do not require stack frames, but if you make a blast layer with branches, such as in here, you'll have to select all stack frames or launch with no verify. Both of the templates here will, well, Minecraft and the Project Zomboid one will both automatically run with no verify. But if you're running something else, or maybe you can't run with no verify for some reason, you should select this. Compressing the corrupted thread, that's also going to take a while. There's no good reason to do that, honestly. And then the threads. Keep this probably at 4 or 5. On all of the processors I've tested it on, 4 and 5 have been sort of a sweet spot. This will make it run about like twice as fast, maybe more. And then here's the really interesting thing. You can limit classes and methods. So say you're corrupting Minecraft and you don't want to corrupt anything except for how cows render. So you might go in here, then you could type, I don't know, cow module renderer, right? Whatever the actual name of the class, it's going to be obfuscated. It'll probably be like ACF. In Minecraft's case, I believe it takes in the whole path, net/Minecraft. And yeah, you can add as many of these as you want. And then you can also specify methods within those. That includes the method name and the descriptor. So maybe had a method called add, and then I. That would select the add method in either of the classes that you might have here. And then if you don't have it, then it won't check for methods at all. And it'll corrupt all of the methods inside of the class. Again, that's a more advanced feature. Yeah, that's about everything you need to know. Good luck and have fun.